Alright, so yesterday we looked at solving systems of equations using a graph. Today we're continuing to solve systems of equations, but this time we're going to use a different method. This time we're going to use algebra to do it, which is going to be a lot less tedious than graphing the two equations. So let's look at the equation, or the system of equations. X plus 2 equals y equals negative 2, and 3x minus 2y equals 10. What we can do is try to eliminate one of the variables. This is the method of elimination. We can either get rid of the x or we can get rid of the y by adding or subtracting these two equations. Notice that if we were to add the second equation to the first, this 2y and this negative 2y would cancel out. So let's go ahead and add these two equations and see what we would get. If I take the x and add it to the 3x, I get 4x. If I take the positive 2y and add it to the negative 2y, I get 0. And then if I take the negative 2 and add it to the 10, I'm going to end up with 8. So I have 4x is equal to 8. Let's divide both sides by 4. We get x is equal to 2. Now that I know x is 2, I can plug it into either of these equations. We'll go ahead and plug it into the top one. Over here, we get 2 plus 2y equals negative 2. All I did was plug in my x for this x here. We'll subtract 2 from both sides. We get 2y equals negative 4. Divide both sides by 2. We get y equals negative 2. We have an x value, we have a y value, so my answer is at the point 2, negative 2. Let's look at a second example. Let's say I have the equations, or the system of equations 2x plus 3y equals 2, and also 3x minus 4y equals negative 14. This time it's going to be a little trickier to find out how to eliminate these. My x's don't match up, my y's don't match up. It's not going to be very simple to eliminate either. What I can do is choose a variable and think of what the least common multiple between that variable's coefficients are. There's two ways I can do this. I can either choose the 2 and the 3, or I can choose the 3 and the 4. I'm just going to choose the 2 and the 3. They're smaller numbers. They look less scary. The lowest common multiple between 2 and 3 is 6. So I'm going to try to make both of these variables 6 so that they'll cancel out. So how I'm going to do that is I'm going to multiply this top equation by 3. And that's going to give me 6x plus 9y equals 6. I also want this x below to be 6, so I'm going to multiply this whole equation by 2. And I'm going to get 6x minus 8y equals negative 28. Now notice I have the same coefficient for my x variable, so it should be easy to cancel that out. To do that, I'm going to subtract. Last time we added, but this time we're going to subtract the bottom equation from the first, because 6x minus 6x is going to get rid of that x variable and give me 0. 9y minus negative 8y is going to be the same as 9y plus 8y. So I'm going to get 17y. 6 minus negative 28 is the same as 6 plus 28. I'm going to get 34. So I have 17y equals 34. If I divide both sides by 17, I get y equals 2. Now that I know y equals 2, I can put it in for either of these y's up here. I'll just go with the top equation. 2x plus 3 times 2, because that's my y, equals 2. And now we're going to solve for what x is. So 2x plus 6 equals 2. Subtract 6. 2x equals negative 4. Divide by 2. We get x equals negative 2. I have an x value. I have a y value. So I know my solution is negative 2. Now we're going to look at one more system of equations, and this time I'm going to show you a different method. In the last two methods we used elimination to solve for that system. Now we're going to find the solution to that system by using a method called substitution. So let's say I have 3x minus 2y equals 10. I also have 4x plus y equals 6. In order to use substitution, I have to choose a variable to solve for. I think the easiest variable to solve for is going to be this y right here because it doesn't have a coefficient. So I'm going to go ahead and solve this equation for y. So since 4x plus y equals 6, I can subtract 4x from both sides. I get y equals negative 4x plus 6. Now I know y is defined as negative 4x plus 6. So I can put that in for my other y because all the y's are the same. So we can say 3x minus 2. Let's plug this in for y. Negative 4x plus 6 equals 10. Again, that's this equation right here. We'll distribute the negative 2. So 3x minus 2 times minus 4x is going to give me plus 8x. Negative 2 times 6 is going to give me minus 12 when I distribute. All that's equal to 10. Let's combine like terms. We get 11x minus 12 equals 10. Let's add 12 to both sides. We get 11x equals 22. And let's divide both sides by 11 to get our final answer for x of 2. Now that we know x is 2, I can plug it into either of these equations over here. We'll just choose the top one. So 3 times 2 minus 2y equals 10. I'm trying to find out what y is. So I have 6 minus 2y equals 10. I'm going to subtract 6 from both sides. I get negative 2y equals 4. Let's divide both sides by negative 2. I get y equals negative 2. I have my x value. I have my y value. So I have my coordinate, which occurs at 2, negative 2. Again, our method of elimination would have been perfectly fine for that. I just wanted to show you the other method called substitution. You're going to have to choose which of those two you prefer, or which one makes sense for the problem you're working on, and then solve for that system or that system's coordinates accordingly.